In this video, we'll be looking at the second type of algorithmic thinking, which is called pseudocode. In the previous video, we looked at flowcharts, which are a visual mean. Pseudocode is much more closer to your code-like language. Now, the idea of pseudocode is it's meant to be high level and English-like, which means it's meant to be as close to as possible to native conversation. So you can see some examples here of some older programming languages, such as Fortran, Pascal, and C. You'll find that older languages such as those are almost identical to pseudocode. There are a couple of rules for pseudocode. The first is, just like flowcharts, you should only write one statement per line or one instruction. Now, the temptation is to put multiple instructions in there. The only time where I would say it's okay to have multiple instructions in a line is one, if you're entering or receiving large volumes of data, you can comma it out, such as the example there of read name, hourly rates, and so on. The other is that, and sometimes when you're working with loops and so on, that it is much more handy to be able to increment a counter and loop for a loop. But generally speaking, you should try to simplify one instruction per line, as the idea of pseudocode is it's a design tool, and you are trying to work out whether your logic is efficient or has any flaws inside it. The second, which is not essential, but you should capitalize what we call reserved or initial words. So what we mean here is any word that can't be used as a variable, such as a control structure or data structure, should always be capitalized. And the reason for that is that we're indicating to the user that we are starting a new type of structure, whether it's data or control. If you don't do this in exams or anything like that, it's okay, you won't be marked down. But as you read other people's pseudocode, you'll find it helps increase the readability. The next, which you'll find in more advanced pseudocode, is that we should always indent to show hierarchy. So what this means is that you'll find as we go through code, some control structures take precedence over others. So for example, sequence, which is the beginning, middle, and end, which every program has, basically takes precedence. Anything inside a sequence, such as other control structures, must be indented to show hierarchy. So here's an example. You can see here that we have a sequence here, and then we have an if, what we call binary or if statement, and we've indented to show that one, it's a different type of control structure, but two, there are two conditions that we're testing here. So here, we're saying if your gross pay, which is your take-home pay, is greater than 100, then we perform this calculation. Otherwise, you get no deduction. The next one, which is a pet peeve, is make sure that you always end any control structures. So if you open up an if, you always have an end if. If you open up a loop, you close the loop. Now, I know some modern programming languages like Python don't do that. They discourage it. But you've got to remember, yet again, that pseudocode is designed to make sure that our logic is sound. And that means if we've got multiple control structures inside one pseudocode, we want to make sure that we are closing them off or using them correctly. And this is something we'll cover in more detail in future videos. And I think the final point that's really important is make sure that you remove all syntax references from pseudocode. So the temptation for many students is to do something in Python, for example, and then reverse engineer it, which means paste it into a Word document and change the syntax out. Now, that's not the purpose of pseudocode. The purpose of pseudocode is as a design tool, which means it should be done first. And the idea is that we're looking to see whether or not there's any flaws in our logic, our reasoning, and whether or not we can do something a better way. Please let me know if you've got any questions.